average speed All right, so here are the two that I'm seeing when I'm looking in there. Oh, man. Damn. All right, so that just changed. One of them had them equal, one of them greater than the other one. So I guess I need you to discuss the merits of E and F being equal there in terms of average speed. Why you're going with them equal. Ooh. And then you can type that in. Boop. All right, so why do you think E and F are equal? All right, and our friends are saying things like, because the amount of distance traveled is the same, they're equal because the total distance for both is 15 meters traveled in 10 seconds, equal distance over time, okay? And so again, when we're looking at total distance on a thing like this one starts at 15 and goes to 0. So clearly it moved 15 meters. This one starts at 0, goes to 10, and then from 10 it goes back to 5. And you have to look at the total distance moved in each segment or total it up. So 10 plus 5, 15 meters. Okay? Different displacements, but the same total distance. Ooh, we got to play that game at some point. All right, so what did we have? So it's F equal to E greater than C greater than D greater than A equal to B. All right. Cool. So then we're going to slide on to this thing. I don't know that I liked how we did it last hour, but try it again. See if it was just the people. You got 2 people in your group, so I'd like you to look at not frozen screen. And I don't know, maybe we didn't hand this out the other day, but it should be over here now. Motion maps and position versus time graphs worksheet. We're just going to worry about question 1 and question 2 on here right now. So one person in your group does number 1, the other person does number 2. In the end, I'm going to have you come up and fill in the key for us. So like be able to explain why you're doing what you're doing. That's why you got your partner. After you do number 1 and they do number 2, you're going to explain number 1 to them. That gives them a chance to ask you questions. Make sure what you're doing seems reasonable. Okay? So how about that? Okay. So just a quick little tutorial on the pen if you've not used one before. So I just write on the screen like I write with a pen, and then if I need to erase, there's a little button here. It's a rocker button. It kind of goes psh, 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 psh. If you push down the button end that's closest to the tip, that's the eraser. It only took me like 7 months to figure that out. Well, what? Don't worry about it. Yeah. It ends time as we know it. So don't push the back button. All right. All right, there we go. So, all right, your buddy, you want to come on up here?
So I have to like write out the described
Yeah.
motion.
Oh, your choice. Do you want to do the motion map or write out the description?
Or just do the motion.
And then Wilbur, your job is to look like a 10-year-old kid that's been made to go shopping with their parents even though they don't want to. So now you're not doing it.
Okay.
There you go. So you like kick things and side heavy. Oh, there we go. You got it. The next partner gets to be the 4-year-old that does not get the fire truck shopping cart at IB. Hell hath no fury. Alright, so can you hey, tune in, friends. Talk us through what you did there.
So for the first 2 seconds, it increases its position until it gets to 4 meters, and then it stays there for a second. And then for the next 4 seconds, it decreases its position until it returns to the starting point.
All right, Peanut Gallery, if you got questions on that, hit me up over on the paradigm. And again, we haven't really done a lot of these yet, so you might have a genuine question you're just not sure about. You're not sure if you're right or wrong. You just want to know. That's how you find out. Next question. All right. Our first friend would like to know. Oops, that's not the button. Our first friend would like to know. Why did you put the dots above the number line?
I didn't really have a reason for doing that.
Coin toss, right? Above the line or below. I allow that like personal preference. If you like, if you're below the line type of person, that's okay. Then the other one was, how did you determine the order?
I started with the beginning of the graph at 0 seconds, and then went to 7 seconds.
And then one thing I think we talked about this maybe on the day that you weren't around. If you want to like just kind of help out the viewer a little bit, because sometimes people might think that it started out at 4. If you could circle the first dot on your motion map. So which one is the first dot?
That's kind of.
And that'll hopefully help out the viewer. That's the dot that it starts at, and then you can tell it goes out to 4, it stops there for a mile, and then it heads back to 7. Let's see what else we got. Question here, how did you determine where to start the motion map at 0 seconds for the first point?
Because it starts
Kind of
at,
how that,
yeah.
That's kind of how the, sort of the general consensus on those is the initial dot represents time 0, And then there's got to be some kind of explicit statement, which I think there is here, that each dot is then for each second, 1 dot per second. And then reading the motion map, so it starts at position 0 at time 0. Then it reaches 4 meters in 2 seconds. This way of showing that it's at that position then at 3 seconds as well. So stacking the dots is kind of how you show multiple points in time at the same location. If you just drew the dot on top of the previous dot, it'd be tough to know how many dots are there. So if you stack them vertically like that, then you can see, oh, okay, at time 2 and time 3 seconds at 4 meters. Let me ask the peanut gallery a question. Should there be a dot? Should that last dot be there? I guess that's what I'm asking. Should there be a dot back at 0 again? That was a question somebody asked last hour. Uh-oh, something's getting a whack.
No, that's just
Oh. I didn't say be a gangster for the 1970s. Save it for all right. Better than a school board election, but not everybody. We got 12 folks saying yes, 2 people saying no. Yes to having a dot there. Why did you put a dot there? At 0 meters again.
Just kind of made sense to me.
Because it's back there, right? According to the graph, it arrives there. Yeah.
We put a dot every second, and it was the 7th second. So we put a dot at one of the second marks.
There you go. 7 seconds worth of data. How many dots then? 8 dots.
Well, 8. Because you put 1 at 0, 2, and then 1. So
yeah. So be mindful of that. 8 dots represent 7 seconds worth of data. All right, cool. Let's pick somebody else to have to do the verbal description.
Well, I didn't do anything.
And let me tell you this too, with the verbal description, here's kind of a guideline for it. Be as efficient as possible, as concise as possible. But if I handed your verbal description to somebody, we would want them to be able to basically recreate the graph, okay, from scratch. So let's hear from. Stay up there. All right.
Okay.
Look at that. That's fun.
Do I write it?
Moral support. All right, Ari, it is high B during the busy time of night, 5 p.m., and you didn't get the pink fire truck cart that you wanted, okay? So throw a little bit of a strop up there. You don't smile. I want shrieking. I want
How do you write on this?
snot and mucus everywhere. Make a show.
I'm not very good at this.
Hang in there, Jules.
oh, it's now. I thought it was. Oh, no. I thought you were having a stroke. Well, that was scary. For a second, I thought Kevin was responding to that. Those are always fun days when people continue to participate in the Paradise Long Week. Text and book, you might as well be able to hear it. Wilbur, you good?
I think so.
Okay, so can you read that to us?
Increases from 0 to 4 meters over 2 seconds, stays at 4 for 1 second, decreases from 4 to 0 meters over 4 seconds.
I like it. One thing I would add here is what increases from 0 to 4 meters.
Position.
So go for that. That's really the only thing we have right now, but we'll have other things later. So let's just get to have it.
Just throw position at the beginning.
Throw position out. So position increases from 0 to 4 meters. Seconds. You
Okay.
have to be a dummy not to see that it said 4 meters. Realize there's a lot of dummies.
Why? Yeah, it could
Over
be
2
why.
seconds stays at 4 for 1 second. Decreases from 4 to
0 meters. I just said M every. I don't know.
lots of meters. Lots of meters. It's filled up the space pretty well, so I think we're pretty much there. Maybe carrot it that the position increases at a constant rate.
Okay.
Do you want to
Well,
carrot
we're
that?
assuming constant position, like constant velocity right now, aren't we?
Yeah.
For everything.
I think good to get in the habit of describing it that way, though.
Sure.
And then that rate is the rate the same in the first and third parts of the motion?
No.
What would you say about the motion in the end? Faster or slower?
It's fast. Slower. Sorry.
Okay. How do you know that?
It's the slope. We're saying that slope is equal to velocity right now.
Yep.
And the slope for the increase is 2, and the slope for the decrease is -1. And I don't know, 2's greater than 1.
Visually looking at it, you can see steeper in the beginning and a little flatter. Okay. Cool. I think we're good. Go ahead and scroll down to the next problem. However that works. All right. Let's pick on somebody else. I'm still in the mix, so I wouldn't walk too far. I like your group. Nobody? Okay. All right. Just trying to get in front. All right. Pulse and friends. Hop on up there and talk to us about. You can choose the graph or the written description.
Sure.
All right. They're gonna have the graphs. We'll find something fun to talk about. What do you got, Nelson? To get the conversation started. Is a hot dog a sandwich?
Yeah, sure.
Okay. Have that discussion with your neighbor.
Go ahead.
I said I suck at this.
Okay.
I can't keep my hands suspended.
1, 5. That's 5, right?
Yes. Move it to.
1, 2, 3, 4, 5. The here?
And then it goes down.
2, right?
Subway sandwich is not a sandwich?
Yeah.
Oh, I did this part wrong.
Oh, this part is wrong?
Yeah.
How much
I
is
just did
it?
it too straight.
How do I erase it?
I have no idea.
Mr. Hardy, how do I erase it?
You push the button.
What button?
There's probably a button on
No,
that.
not at the bottom. No. Okay.
So on the side, and you push it like that.
And it's an eraser now?
I think so.
Nope.
Okay, we'll push the other one maybe,
No.
or maybe it's while you're pressing it.
Oh. Is that?
No.
Oh, don't
definitely
press the
not.
button. You're pushing a button.
How do I erase it?
Oh, you want to erase
Yeah,
it?
yeah.
Okay. So to erase, you're gonna want to push the front button.
Okay.
And then. Yep.
I see.
Put it before it battery.
I did it too steep.
That's cool. Okay. So we go from 5 to 2 and 3. Okay.
Oh, boom! Taco.
So
Is a hot dog a taco? Yeah.
we start here, here, and then
Is a hot dog
here.
a sandwich? Is a hot dog a taco? Is a taco a sandwich?
And then
2 over,
two over. And then down.
2 down.
then 2 over,
2, oh, yeah.
then up to 4.
1, 2, 3, 4. Oh, okay, that's just. That was not right.
I don't consider talking. My dad.
1, 2. Wait, is it 4? How does that go up? So it goes here.
Yeah.
I don't know how that. Oh.
That's
Oh.
absolutely no basis.
Okay.
Okay, you don't either. Okay.
Yes, that looks right.
How's a burrito is wrapped? What? A soft shell taco is not wrapped. Okay, but like, it's just. Is it quesadilla wrapped? It's wrapped. Yeah, because the cheese on the outer layer closes it in, so it's wrapped. It's enchilada. That's wrapped.
No, you wrap something by encasing something.
Yeah, it's a cheese and queso thing.
Wait.
It's the adhesive that.
No, there's no over.
I can touch a burrito. I can touch a burrito all over the surface, but I'm touching the filling.
No, that's
That's
a
not
lot.
necessarily true.
Oh,
Versus
right.
bad that's making.
The top.
Okay,
I guess yes.
We're talking Riverside Drive Ponchos, not like all Ponchos. Not Fort Dodge Ponchos. Fort Dodge Ponchos. All right, we got a graph?
Anyway, yeah.
All right, cool. Let's turn back to these lines. That was all recorded for posterity on the screencast, by the way. So let's probably go back and do that. All right. Can you talk to us about your graph based on that motion map, please? Thank you.
All right, so it first, it starts at 5 meters, and then it goes down at 1 meter per second for 3, and then it stops for 2 seconds, and it goes down at -1 meters per second another 2 seconds, where it again stops for 2 seconds, and then it goes 2 meters per second for 2 seconds till it hits 4 meters.
All right. So the paradigm is open. If you got questions on that, hit it up. All right, let's see here. So the question is, how did you determine where the starting point was?
The first point on the motion map, which is 0 seconds, and that was at 5 meters.
I think what they might be asking is like, why didn't you start it down at the bottom left corner?
Oh, because it goes in one direction. So if you were to do it at the one at the very bottom, it would be like going off them.
So kind of like vertically, like.
It'd be going like the wrong direction.
Okay. So I think our example of the previous motion map, like vertically went up. We would expect this one to vertically go down, so not jump up a level and then come back down again. Like I don't know if what I'm saying is making sense, but it's kind of got a sequential thing vertically going. This one is going downward. And unfortunately, these printed motion maps don't always have a circle around time 0.
You can tell which one's 0 because the initial position will not have an arrow drawn towards it, if that makes sense.
I'm just thinking from past experience, I've seen people given a motion map like this start at the bottom left corner.
Okay.
How? Mine is not to wonder why, mine is what to do or die. I don't know if it just started there. It's bottom left corner. And then they say it went out to 5 meters and then it came back.
Oh,
Smell me?
I see.
Yeah. All right. All right. Question for you. Why is there not an end point on the motion map?
Because it just continues like that. As far as when it just continues going 2 meters per second.
Yeah. And this is, again, one of those other motion map existential dilemmas. Does there have to be an arrow on the last point or not? Like, all this is telling us is that at 11 seconds, it was at 4 meters and it was moving at a velocity of, did you say that's 1 meter per second? 2 meters per second.
At the end, 2 meters.
Okay. Yeah. So that's kind of a little bit open to interpretation. It's clearly not stopped at 4 seconds. There's still an arrow attached to it. Okay. Question on verbiage, preference for remains at rest or stops. I'll take either of those. Question on whether there should be an arrow on the graph. I'll take that. Just have the graph ending like that. It's okay. So then I think we're good. All right, cool. It's about that time, so we'll just call it good there, and we'll pick on somebody else to do the verbal description tomorrow. We're going to get into another lab. Where's some comfortable walking shoes tomorrow? Charge up that fitness. Here's Mike's guy. Work on your band walk. Oh, yeah, wear your band shoes tomorrow. There you go.